facts about functions is what we're at on page 19. It says today students will continue to investigate representations of functions and characteristics of those functions, including functionality, dependency, linearity, domain range, and using various representations. So we're going to kind of pick up where we left off last week. So let's go ahead and take a look on the first page. Facts about functions. First of all, on number 1 here, they ask us to identify which relations are functional and explain your reasoning. Before we can do that, let me remind you that we first said a relation is nothing more than a set of ordered pairs. So all we're given here is a set of ordered pairs. What we've got to decide is whether those sets of ordered pairs are considered to be a function. So, function. That's one of those words I asked you guys on your way out. You had to know that word. So, can anybody tell me what the word function meant? What did we say function was? Set of ordered pairs where x's don't repeat. Very good. It's a set of ordered pairs where the x's don't repeat. So that's what we're going to be looking for in each of these examples. So if we look at part A here, we have a set of ordered pairs. We call this a relation. What I want you to do is circle all of the x's. That's what I'm looking at right now. Circle all of the x's. What we're going to do is see if any of those x's repeat. Yes. What repeats?
3.
3. And because that 3 repeats, this is not
Functional.
a function. So what I want you to do for me is write down that this is non-function or not a function. And the reason it's not a function is because of that 3 that repeats. You'll notice that the 3 has a 2, but the 3 also has a 3. It has 2 different y values. That's not allowed in a function. So again, first example A, it is a relation. It's a set of ordered pairs. It's just not a function. What we're going to do with B is the same thing. We're going to take a look at all the x's, and as long as none of the x's are repeated, then we can call it a function. But if we see any x's repeat, then we have to say, no, it is not a function. So I'm going to do the same thing I did with A. I'm going to circle the x's, and I'm going to see if any of those x's repeat.
No.
No, none of the x's repeated. Therefore, this I can call a function. That is a function. Yeah, I heard that a second ago, guys. You'll notice that the y repeated. A 2 shows up twice in the y values. That's okay. What can't repeat is the x's. So for part B here, this is a function. And the reason it's a function is because none of the x's are being repeated. Make sure you're writing all of this down. All of this down. I'm giving you the answers. Write it down. In a minute, you'll be given your own assignment that looks very similar to this, and I want you to have some examples to go back and look at. So write everything down. C. C and D are also ordered pairs. They're just written a little bit different. C and D are what we call mappings. And in a mapping, you'll notice that there's 2 circles. The first circle is where we keep all of the x's. The second circle is where we keep all of the y's. And you'll notice that coming out of each of these x values are some lines. They're pointing to some specific numbers here. So what we're saying here is this 3 goes with 2, which means we have the ordered pair 3, 2. You'll notice that the 3 also points to the other 3, meaning we have the ordered pair 3, 3. Negative 2 points to 0, and 0 points to negative 1. So all this is telling us is what the ordered pairs are. So what we want to know is, did any of the x's repeat? Did any x get used more than one time?
No.
Yes, it did. Which x got used more than one time? 3. Notice the 3 goes with the 2, but 3 also goes with the 3. So it's being used twice here. And I know that because it's being used Or we've got 2 lines coming out of each one. Okay. So, this particular one is not a function. That's not a function. And the reason it's not a function is because 3 has 2 different y values. It has a 2, but it also has a 3. That's not allowed in a function. Remember, each x can only be used once, not twice. D, on the other hand,
Is it?
by the way, remember, first circle is the x, second circle is the y. What we're looking for is to see how many times each of the x values is used.
Twice.
Notice that 3 is used how many times? Once.
Twice.
4 is used
Twice.
once. Negative 2 is used
Twice.
once. And 0 is used
Twice.
0.
Yeah.
0 is only used once. 0 is only used with the other 0 here. Okay. So this is also considered to be a function, and that's because each x has exactly 1 y value. In other words, we only have 1 arrow coming out of each of these x's. Yeah, we call this a mapping.
I don't get it.
It's just a fancy way of writing ordered pairs. Fancy way of writing ordered pairs.
Is it the last one we did?
Nope. Everyone got this? Now, E and F are also sets of ordered pairs. Now, what we're given this time is a table. The first column are the x's. The second column are the y values. So, this is an ordered pair. This is an ordered pair. That's an ordered pair. And this is an ordered pair. What we're going to do is we're going to look at those ordered pairs and see if any of the x's are being used more than 1 time. Do any x's repeat?
3.
3. Notice how this 3 right here is repeated. We've got 2 different y values. Therefore, this one is
9.
not a function. Not a function. And again, it's not a function because the 3 repeat. Y's are okay. Y's can be repeated. It's the x's that cannot be repeated.
So you know how it says 3 and 3? That's okay?
That's okay.
Oh.
What makes it not a function is the 3's under the x column. Which means if we look at F over here, same idea. This column is the x, this column is the y. Really all we're doing is looking at the x's to make sure none of those x's are being repeated. Do any x's repeat there?
No.
No. And because none of those x's repeat, then it's okay to call this one a function. So that is a function. We're okay there. Alright, so F. F is a function. So on this first part here, basically all we're doing is looking at the x's. If they repeat, then it's not a function. If they don't repeat, then it is a function. Alright, next one, next page. Oh, let me go back. Okay, let me go back over here. There we go. Okay, we got it all written down?
No.
No? Still working on it? So E is not a function. F is a function. All right, I'm going to go ahead and move on here. You can get it from your neighbor. G and H. This time what we have is G and H. This time they give us a graph. So let's take a look here. On G, they give us 4 points. So what I'm going to do first is write down each of these ordered pairs. So let me start with this one right here. How would I write this ordered pair?
2, 0.
Nope.
-2, 0.
-2, 0. That's the ordered pair for that dot, for that point. What about this point right here? What's that ordered pair?
-1. -1.
Oh, read it. 0, -1. There it is. 0, -1. Now let me go to this point right here. What's this ordered pair right there? 3,
2.
3, 2. And then finally, this ordered pair right here is
It's 3, 3.
3,
3.
3. All right, so all I've done is taken each ordered pair and write down their x and y values. Now that I've done that, then I'm going to determine whether or not it's a function. So look at the x's. What we need to do is take a look at the x's and see if any x's repeat.
Yes.
What x repeats?
3.
3's. Because this 3 right here repeats, then this is not, this is not a function. This is not a function, and that's because the 3's repeat. Not a function because the 3's repeat. Now, guys, in this particular case, we only had 4 points, and we went ahead and wrote down the coordinates, or the x and y values. Well, what if I had 20 points, 20 dots? Are we going to sit there and write each point? No, there's no need to do that. There's a little faster way to determine whether or not it's a function. So let me show you how that's going to work. We have something called a vertical line. Of course, a vertical line is just a line that goes straight up and down. If I put my vertical line here, how many times does it touch the dots? How many dots does it touch?
1.
It only touches 1 dot. What if I move it over a little bit? How many
1.
dots does it touch?
1.
1. What if I put it right here?
2.
It's touching 2 dots. If it touches more than 1 point at any particular time, then it is not a function. Okay? So because it touches this line twice, then it's not a function. So let's try that over here with this graph. Let me move it over here. How many times is the vertical line touching the dot?
1.
It's touching how many dots?
1.
1. What if I move it over here? How many dots is it touching? Just 1. What if I move it here?
1.
What if I move it over here?
1.
1. So no matter where I put this vertical line, notice it's only going to be touching
1.
1 dot. And because it does that, then we can go ahead and say that this is a function. But it can only touch 1 dot at a time. This is what we call the vertical line test. As long as it touches the vertical line just once, then it's a function. But if it touches more than once, well, then it's not a function. And we'll use this vertical line a lot more later on. This is just kind of an introduction. So up to this point, all we're really seeing is how to determine whether or not we have a function. We can tell it's a function by looking at the x's. If the x's repeats, then it's not a function. If they don't repeat, well, then it is a function. So all of this is number 1, A through H. Now we're going to move on to number 2. Any questions so far? Well then let's go to number 2 here. For number 2, a couple of things. For number 2, for the set of points, which we have here, got a set of points, determine if it's a function. Let's go ahead and do that real quick here, guys. Do we have a function? Well, let's take a look at the x's. Let me circle them
Yes.
for you. There's the x's. Did any of the x's repeat themselves?
No.
No. So can I call this a function?
Yeah.
Yes. So go ahead and put down yes. Yes, this is a function. There's the first part of the question. Yes, it's a function. And we know that because none of the x's are repeated. But we're not done yet, because they also want to know what's the domain. Well, you remember we said domain is what? The x or the y values?
X values.
X's. Domain is the x. So what they want me to do is list all of the x's. So we're going to write down -4, 5, 0, 1, 8, and -2. So write those numbers down for them. And they don't need to be in any particular order. We just need to make sure we write them all down. -4, 5, 0, 1, 8, -2. Notice how they also asked for the range or the y values. The y values were 5, 6, -7, 0, 9, and -2. Again, they don't need to be in any particular order, but we do need to have those numbers listed. Those are the y values in this set of points. So domain were the x's, range is the y's. We know it's a function because no x's were repeated. Okay, we're going to number 3 now. Number 3, for the table of data, determine if it's a function. So let's do that part first. Is this a function? Look at the x's. Do any x's repeat?
No.
No. So can I call this a function?
Yes.
Absolutely. So you're going to write down yes. Yes, this is a function. No x's are being repeated. Next thing I want to know is what is the independence? What is independence? What is the independent variable? Now, when we say what's the independent variable, we want to know what do the x's represent. So let's look at our table here. What exactly are the x values? It says right here that it's the seconds. So write that down for me. Independent is the seconds. Independent is seconds. Then we're going to identify the dependent variables. Dependent variable are the y values. What do they represent?
Temperature.
Well, it says right there that the y values are temperature. Last part of that question asks for the domain and range, which is just like number 2 here. What are the x's and what are the y's? So when it's all said and done, here's the answers we have. We've got a function. Independent is the seconds. Dependent is the temperature. Domain are the x's. That's the 2, 4, 6, 8, and 10. And the range, those are the y values. That's the 0, the -2, the -4, the -6, and the -8. That's number 3. Okay, we're moving on. Number 4. For number 4, they give us some graphs. For each of these graphs, we're going to determine if it's a function. Once we know if it's a function or not, then we're going to go ahead and identify the domain and range, the x's and the y's. So, this first graph we have here, is this considered to be a function? Well, we're going to use that vertical line test that I was talking about earlier. Here's the vertical line. So watch this. If I take this vertical line, and I were to put it right here, how many times is my green vertical line touching the graph?
Once.
Just once. What if I move it over a little bit? Now how many times is it touching?
Once.
Still only once. What if I move it over here?
Once.
It's still only touching once. No matter where I put this green line, guys, it's only going to be touching once. And because it only touches once, then we can go ahead and call this a function. Okay, so this is a function. So write that down for me. This is a function.
No, wait.
But we were also asked to find the domain and the range. Domain. Of course, we know domain are the x values. Now, the problem is if I try and write down each and every one of these x values individually one by one, that's a lot of numbers to write down, and we don't want to do that. So what we're going to do instead is we're going to say that the domain is all real numbers. In other words, all the negatives, all the positives, and all the decimals that fall in between. So that's what we mean when we say all real numbers. Take the pass. Range, we're going to do the same thing. The y values, if we try and do that individually, that's too many numbers to write down. So we're just going to go ahead and say all real numbers. The second graph we have over here, this U shape, now we're going to determine if that one is a function. So let's take the green line, the vertical line. If I place it here,
it's no longer here.
notice the green line is only touching the U shape just one time. If I move it over a little more, notice it's still only touching one time. If I move it over a little more, still only touching one time. No matter what, it's only touching one time. Therefore, it's a function. All right.
I started this OU, so I'm going to OU.
All right, so this one is a function, guys. Now, as far as the domain on this graph, the domain on this graph is also going to be all real numbers. In other words, the x's are all negative, all positive numbers, including fractions and decimals. But notice my range is a little bit different. And I'll explain that once you write it down. Range. So let me explain why the range is the y value is greater than or equal to -4. Notice this graph goes as low as -4, which is where this -4 is coming from. But the y values only get bigger from there. I have no y value that's smaller than a -4. I've got a -3, I've got a -2, I've got a -1, I've got a 0, 1, 2, 3, 4, and so on and so on. So this is why we're writing the range as y is greater than or equal to -4, because there are no y values smaller than that. Notice the graph does not go any lower than the -4, right? It starts at -4, then it goes just up from there.
So it says y is no greater than
It's greater than or equal to. That's a little equal sign.
We're in the same shape.
Everything above -4 is where the graph is at. That's what that part is at. Everything above negative. Okay, we got two more here. Two more graphs to look at. Next one here for the graphs, determine if it's a function and identify the domain and range. So we're doing the same thing. First of all, both of these are functions. And I know both of these are functions because if I use that vertical line test again, no matter where I put my vertical line, it's always only going to be touching just one time. So both of these are functions. So write that for me. Both of these are functions. Function for the first graph, function for the second graph. Now, here's where everybody usually messes up for the domain and the range. So let me see if we can get this straightened out here. Domain, those are the x's. Notice that this graph is going to fall, and I think I've got the wrong graph here, because I think your graph is slightly different. Mine goes over here to -6. I think yours goes to -5 if you look closely. Is that right?
Yeah.
Yeah, okay. So, the graph goes from this x value all the way to this x value. So my graph goes between -6 and positive 7, right? But of course your graph I think is not -6, it's -5. So what we're going to do is we're going to say that the domain, or the x's, go from -5 to -7. So I want you to write it just like I did here. Now remember, I'm using your graph because mine actually goes to -6. I've got a different graph than what you have on your page. So I'm giving the answer you should have on your page. By the way, I also want to point out that notice one of these has the equal sign, the other does not. Why does one have the equal sign and the other does not? It has to do with the dots. Notice one of the dots is colored in. That's this dot right here. Notice one of the dots is not filled in. That's this dot over here. We only use the equal sign if the dot is filled in, which is why you see the equal sign on this one and not on the other. Because this is the one that had the filled in dot. This one did not. All right, so again, the domain is everything from -5 to +7. That's where this graph falls, between the -5 and the +7. Now let's take a look at the y values. Let me get rid of this here. The y values. The y values go from here all the way up to here. The y values are between the -3 and this +5 up here. So that's where this is coming from. Once again, you'll notice that one of them has the equal sign, the other does not. That's because one dot is filled in, the other dot is not filled in. The other graph, very, very similar here. Let's go ahead and do this one as well. We already said it's a function. We already said it was a function. The domain, or the x values, go between here and here. But again, I think my graph is a little bit different from yours. My graph goes from -7 all the way up to a +7. Yeah. But yours is different. I think yours goes from -6 to +8. So just double check that one. Is that right? Does your graph go from -6 to +8? I believe it does. The y values go from +2 all the way up to +8. So in other words, the graph is in between this area right here. By the way, notice that this time I use the equal sign on both of these. That's because both dots are filled in. This time I want to include both of these points. We're almost done. We got one last thing. Number 5. Last thing, and then I'm going to let you try some more.
What would you put it in there?
Number 5. Number 5 says for the relation y equals x, determine if it's a function, then identify the independent, dependent variables, then state the domain and range, and then graph the relation. So there's a lot of stuff they want us to do here. So here we go. Let's get started. Let me get that. First thing we're going to do is we're going to graph it. And in order to graph it, we need to first start by making a little table. First thing I need everybody to do is make yourself a little table. Now, in the first column, I'm going to put the x's. The second column, I'm going to put the y's. The y values we get are going to depend on what I stick in for x. Here's the numbers I'm going to use for x. I'm going to use a -3, a -1, a 0, a 2, and also a 4. And I just picked these out of thin air, guys. I could have picked other numbers. It's just that's the numbers I want to use.
We can use those, right?
Yeah. All right, so let's see here. If I plug in a -3 for the x, what's 2 times a -3? -6. 2 times -3 is -6. But what's a -6 minus a 3? -9. So the y value would be a -9. Let's use a different number this time. Let's use -1. If I put a -1 here, 2 times -1 is a -2. And a -2 minus 3 would be a -5. Now I'm going to put in a 0. 2 times 0 is 0. 0 minus 3 is a -3. Now I'm going to put in a +2. 2 times 2. 2 times 2 is 4. And 4 minus 3 is 1. I'm going to do this one last time here. 4. 2 times 4 is 8. And 8 minus 3 is 5. Now again, I just chose these 5 numbers. I could have used any other numbers. I could have used 100 numbers. That's just a little Those are the 4 that I chose. So now that I've got this table, I'm going to plot each of these points, each of these ordered pairs. So I'm going to start with -3, -1. Let me find that one. -3, -1.
What did you get?
Oh, I'm sorry, -3, -9. That's the one. Just making sure you're awake. -3, -9 is down here. The next one is -1, -5. Let's find that one. -1, -5 right here. Then I have the ordered pair 0, -3. That's this one right here. Then I have the ordered pair 2, 1. And then I also have the ordered pair 4, 5. 4, 5 right here. So these are the points that we end up with when we plug in those specific X values. What do you notice about the dots there? They make a pattern, right?
Go
What's the pattern?
diagonal.
Kind of looks like a, what? A line. Let's go ahead and connect these dots, guys. Because really, I could have chose a lot of other X values to get this graphic. So we're going to include all of them. So let's go ahead back and answer these questions here. Is this a function?
Yes.
Yes. Yes, this is a function. And we know that because no x's are repeated. Independent. Independent. What are the independent variables? Well, in this case, the independent is the x's. That's what I have in my table here. The dependent is the y. That's what I have in my table right here. State the domain and the range. Domain. The x's. What are the x's?
-3, -1, 0, 2, 4.
But those are the numbers that I chose. Were there other numbers that I could have used as well?
Yes.
Yes. So I want to include all of those. What is that? There you go. All real numbers. In other words, I could have used -5, -10, -2.5. A lot of other numbers that I could have used. Range is the same idea. The y values could have been anything as well. They could have been any real number. All real numbers. All real numbers. Now, I'm going to go ahead and skip B because we're running low on time here. I want to give you some time to get some on your own. This right here is how to find whether or not we have a function or not. Right? So, let's go ahead and stop that.